Okay, so we just went over how to graph basic points, right? So now that we know that, we can actually now graph equations. So I'm going to go back to my dog park equation, right? Graphing equations. So the dog park one was 30 equals 3x plus 2y, right? That was that equation. And then we actually found two of the points, right? It was if x equals, I'll have to go back up, sorry. X equals 5, y is 7.5. And then the next one was x equals 6, y equals 6. So another way you can do this is just make a table. And then what this table tells you is the ordered pairs. These are points. For the x value of 5, the y value is 7.5. For the x value of 6, the y value is 6. And you can plug in whatever numbers you want. So let's try it if x equals 4. Okay, so if x equals 4, I'm just going to plug it into my original equation. Right, so if x is 4, y is 9. Right, and you can keep doing this depending on the problem. They might have like 5 slots and they say fill in this table, and you can just fill in with whatever numbers you want. Sometimes maybe they'll give you all the inputs and you just have to solve for the outputs, but otherwise it's just substitution, which is and it's what you did last week with functions, where you just plug in the input, which is the x, and you solve for the output, which is y. Last week we used f of x instead of y, but they're the same thing. Don't ask me why algebra likes to do it that way, but I'm teaching it to you both ways so that you know if you ever see it. Okay, so we can graph this line now. We have a bunch of ordered pairs and we can put them on a graph. So, and especially when you're graphing lines, I definitely use graph paper, or there's actually a graphing website where you can just like easily put in the coordinates like this, and it'll put it on a grid for you. I cannot remember what it is off the top of my head, but I will link it in the description box below for you so that you can, if you want to do an online graphing type of thing. Right? Okay. Which might come in handy when you're doing problems and you need to find, it asks you questions about the line. Okay, so don't mind my graphs when I'm doing these lines because they will not look straight. All right, so the first point is 5, 7.5. So I'm going to go to x first, start from the origin. I go 1, 2, 3, 4, 5 to x, and then I go up 7.5. So 1, 2, 3, 4, 5, 6, 7.5, somewhere around there. So that's my first point. Okay, and then the next one is 6, 6. 1, 2, 6. So that's about right here. Okay. The next, oops, my axis doesn't go high enough. Okay, and then 4, 9. So you can see how it's just a little bit curved, but if you did it on an actual grid or graph paper, you should have a perfectly straight line. Right, so we just drew this equation. So why do we do these lines? Right, they can tell you a lot just visually. So you can see that as, right, this is the x-axis, this is the y. As x gets bigger, what happens to y? It starts getting smaller, right? We're seeing a trend in the data. And that makes sense, right? If I want to make my fence wider, then I'm going to have to take away fencing from the length, and I'm going to make my length skinnier and skinnier, right? And vice versa too. If I make X smaller, then Y gets bigger, right? So I see these trends in the data. Also, every single point on this line, and if you had a nice grid, you'd be able to like actually pick points, but I can pick any point on this line and I can plug the point in, right? This point's going to give me a coordinate, right? It's going to be some kind of X comma Y. You'd have to see where it like lines up and everything, find the coordinates. Like if I'm just guessing, I think this is 1, 2, 3, 6, 7, 8, 9 comma 4, but I'm not going to put it in because I don't have a nice grid. But you can plug these points into your equation and you should get two sides equal to each other. Right, so you can check your points. You can check any point on this line, plug it into the equation, and it'll work. Right, and so this line represents all the possible right answers to this equation. Okay, so let's just do one more. We'll do one more little equation. What should I do? Right, so let's graph this line. I'm going to make a table. And when I'm making a table, I always like to pick small numbers because I just find it easier. Okay, so maybe I'm just going to get 4 points here. I said X is 0, 1, 2, 3. You can pick whatever numbers you want. So if X is 0, right, then we have 0 minus 2y equals 6. So then, therefore, y equals negative 3. Okay, 1 minus 2y equals 6. Therefore, I'm just solving the equation, right? 5. Y equals negative 2.5. 2 minus 2y equals 6. Y equals negative 2. 3 minus 2y equals 6. Y equals negative 1.5. Okay, so this is my y coordinates. So I have all my points. If it helps, I can rewrite it like this. Right, x comma y. Okay, and let's graph it. We're going to graph this line. And the truth is, you only actually need 2 points to make a line. Right? Those 2 points are just like anchors. You draw a line through them, and then once you draw the line through them, all the other points will fall on the line. Right? Not in my case because I'm not using a grid, but when you use actual graph paper or grids, then you really just need 2 points. So I'm going to just graph these 2 points, 0, negative 3, and 2, negative 2, just because they're nice whole numbers. Right, so 0, I stay at the origin, and then I go down 3. So that 0, negative 3 is right here. Okay, and then I'm going to do 2, so I go to 2 on the x-axis right here, and then down to negative 2. Right, and then I draw a line through it. And then my other points should line up on it. 1, negative 2.5 would be right there. See, that works out. 3, negative 1.5, that looks about right. So these points, even though I didn't graph them before, they still line up on my line, right? So this line represents this equation. All the points on this line, I can plug into this equation and it'll be true. One side will equal the other side. Right, so that's how you graph. That's the basics of how you graph equations. You really only need 2 points. Okay, so now we're going to go over things like slope and intercept.